So ladies, so far in this chapter, we've talked about general sequences and series, arithmetic sequences, and today we're going to talk about geometric sequences and series. So let's take a look at Goal 1, Part A. We want to recognize, write, and find the nth terms of geometric sequences. So how do we know when a sequence is geometric? Well, we know that a sequence is arithmetic when there is a common difference. A sequence is geometric when the ratio of consecutive terms are the same. So the ratio is called a common ratio and is represented by the letter R for ratio. So to determine the ratio between consecutive terms, you will divide the nth term by the n minus 1 term. What does that mean? Well, if you have the fifth term, if this is a sub 5, then the term that's n minus 1 would be the fourth term. So in other words, you pick two consecutive terms and divide the second by the first. So the common ratio is equivalent to the nth term divided by the a sub n minus 1 term. Let's look at example 1. We have a sequence here. The terms are 1, 5, 25, 125, and 625. So to find the common ratio, we take the first two terms and we divide. 5 divided by 1 is 5. Now, if I want to confirm that this is indeed geometric, I need to check to make sure that the ratio is common between more than just one pair of terms. So I'll now use the next two pair of consecutive terms, 25 and 5. So the ratio is 25 divided by 5. That is also 5. So I see that the common ratio is 5, and if you found the quotient for 125 and 25, 625 and 125, you would find that they also have a common ratio of 5. What I'd like for you to do right now is to pause the screencast and see if you can't determine the common ratio for 2, 3, 4, and 5. Let's see how you did. The common ratio for the sequence number 2 is negative 1/2. Negative 48 divided by 96 is negative 1/2. I probably would have selected these two values. 6 divided by negative 12 is negative 1/2. Number 3, the common ratio is 2. So if you are sometimes it's intuitive to look at this and know, oh, this is going to be multiplied by 2 each time to get the next term. But if it's not intuitive to you, because this is a general term, let's find the first few terms. We know that the first term is 2 to the first power. The second term is 2 to the second power. The third term is 2 to the third power, and so on and so forth. So to find the common ratio, remember we select two consecutive terms, and we divide the second term by the first term. 2 to the third divided by 2 to the second is 2 to the first. So that shows our common ratio. Number 4, the sequence whose nth term is negative 1/3 to the n. Again, pretty intuitive here. We know that if we're raising to the nth power, then we'd have negative 1 to the first, to the second, to the third. So in other words, we're multiplying by negative 1/3 each time. And finally, on number 5, if we find the ratio between the first two terms, 4 divided by 1 is 4. And if we check and find the ratio between the second two terms, 9 divided by 4 is not equal to 4. So we see that there is no common ratio. And if there is no common ratio, then that tells us that this sequence is not geometric. That doesn't mean it's not a sequence. That just means it's not a geometric sequence.